Hello, hello, and welcome to the festive tech calendar of 2022. My name is Tidjani Belmansour. I'm your host today, and we'll be talking about how to test your Azure infrastructures.
So let's talk about automating your Azure infrastructure. I'm your host, Tidjani Belmansour, Microsoft Azure MVP. You can reach out to me either on Twitter or LinkedIn. Let's first get started with understanding why we should test our infrastructure. And as you may know, organizations are now taking the IAC approach, where IAC stands for Infrastructure as Code. And how did they do that? They do that by scripting their infrastructure. This allows those organizations to treat their infrastructure lifecycle in the same manner as they treat their application lifecycle. In other words, in an iterative manner. This has the advantage of matching the infrastructure version with the application code version. The thing is that many organizations often forget to bring automated testing into the infrastructure lifecycle. And by testing our infrastructure, we want to ensure that the deployed version of the infrastructure is compliant with the one that we just scripted. In other words, we want to ensure that what we've deployed is exactly what we were expecting to deploy. There are many use cases or many scenarios where you want to test your infrastructure. The first and most obvious is when you want to improve your infrastructure over an existing version. Maybe you want to add some services, remove some services, or either modify some versions of the services, and you want to ensure that these modifications do not bring down your whole infrastructure or do not have some side effect on the other untouched part of your infrastructure. The second use case, an obvious one too, is when you deploy a new infrastructure. You want to ensure and validate that what you've deployed is exactly what you were expecting to deploy. And finally, a third use case is when you want to adjust the configuration of an existing infrastructure, and you want to ensure that this adjustment or modification have no impact over the untouched part of your infrastructure. An example of that is if you add a subnet to your VNet, or if you open some ports in your firewall. You want to ensure that you are not putting your organization at risk, or you are not giving too much access more than necessary. And for the subnet example, you want to ensure that you are not conflicting with an address space of another existing infrastructure, another existing subnet. One question that arises is that is it worth it to test our infrastructure? And the short answer is yes, obviously. The fact is, once you understand the basic and techniques of how to test your infrastructure, it's not that hard. Actually, it's quite simple. And it's hugely beneficial. You will improve the stability and reduce the risk over your infrastructure and over your overall organization. So you really want to take that step. Now let's see how do we test our infrastructure. And we'll first use a tool called Pester. It's not the only tool, but it's the one that we'll be focusing on during this session. And Pester stands for PowerShell Tester. It's actually a PowerShell testing framework written in PowerShell, and that allows us to test PowerShell scripts, but not only PowerShell scripts. Okay. What can we do with Pester? It's essentially writing tests to validate either entire environment or computer deployment, database configuration, and everything related to an infrastructure. For example, an address space for a VNet. And you have the link to the Pester project. It's pester.dev. If you want to learn more about that framework, you can head to that URL. But we'll cover the basics of Pester in today's session. So essentially, Pester is a PowerShell module. So we need to install and import a module. We'll see how we do that later on. And Pester follows a convention, a file naming convention. Okay, it's not you are not forced to do that, but if you want to take advantage of existing project or existing scripts, you will want to understand and follow that convention. So for each script that you want to test, you will write a corresponding .test.ps1 file which contains your actual tests. And Pester brings us with a set of useful functions to write and define our test. Some of these functions are describe, context, should, mock, and so on. So we'll see the basic one in upcoming slides. And one thing to note here is that Pester is not specific to Azure. We'll see an example of how to use Pester to test an Azure infrastructure, but you can use it to test any other infrastructure on any other cloud like AWS, GCP, and even on-premise. So now that we understand why we should test and how to do those tests, in other words, what to use to perform those tests, let's focus for a moment about what to test. What exactly should we be testing here? There are many things that you want to be testing, and the basic things, or at least the minimal things that you should be testing, are the resource naming convention. If your organization is following a resource naming convention, you want to ensure that the created resources follow that convention. Tags, if you use tagging, which is a powerful tool to classify and query your resources. And for tags, you want to test both their presence but also their values. Obviously, you will want to test resource types. So if you create a virtual machine, you want to ensure that the resource is actually of type virtual machine. You want to test the resource SKUs, if it's from the right SKU. You want to test the number of instances for each resource that you are creating. You want to test the relationship between those resources. For example, if you create an Azure service bus with multiple queues, you want to test the properties of that queue, and you also want to ensure that the queue actually belongs to the service bus that it should belong to. And you want also to test resource configuration, for example, connection string values, app settings, whether you or not you enabled HTTPS only or always on. Do you have the minimal TLS value that is requested by your organization as part of their security standards? And pretty much anything worth validating according to your standard and your organization standards, you should write a test for that. Now let's focus on how to use Pester. There are actually 4 steps to use Pester. The first step is to import the Pester module. The second step is to write our test. The third step is to create a parameter file for the expected values, which is a partial data file. We'll get into that in a moment. And finally, run the test. But there is a prerequisite for that. In order to load or import our module, we'll first and obviously install that module. So we can run that command, install module Pester. And the good thing is that we only need to do that once per machine or server. Okay, so if we already installed our module, we don't need to run that command again and again and again. Now that our module is installed on the current machine, we want to import it into our context of execution. So we do that by running the import module pester command. Next, we want to write our test, and here we have a basic example of test. So as you can see here, we are passing some parameters to that test. In this case, the resource group name, and we are saying that this test is mandatory. Okay. Then we obtain the resource that we want to test. And obviously this resource is already deployed, or should be already deployed onto Azure. So we get that resource group for which we pass the name as a parameter. And then we run some tests against that resource in order to validate its existence and its configuration. So here, for example, we have a describe block, which states that in that block we are validating our resource group. And here we have two tests described by the it block here. So we have two it block. The first test states that our resource group name should have the right value, or not the resource group name, but our resource group should have the right value. Okay. So how do we validate that? On that resource group object that represents the resource group that is deployed on Azure, we'll check its resource group name property, and it should be that value. Okay. The second test ensures that the resource group has been deployed in the right location. For me, it's Canada Central, so I want to ensure that the location property of that resource group that is deployed on Azure is actually Canada Central. Easy, right? But here you see that I have hard-coded values. Okay, so this is not very useful if I have multiple Azure environment. Let's say I have a dev and a UAT and a production environment. I will not want to replicate that same script, that same test script over and over. What I want to do is to have only one version of that, but the values here should be coming from some parameters files. And that's exactly what step 3 is all about. So here we've added a second parameter, which is the path to that PowerShell data file containing the expected values of our environment to be tested. And here we first load that data file into the expected variable. Next, as we did earlier, we obtain the resource group that's deployed on Azure, and we do the same test here. The only difference is that instead of having the expected values hard-coded, we are obtaining them from that data file here. Okay, so here, for example, for the resource group name, in my expected file, I have a section called resource group, and in that section I have a key value pair named name, which represent the name of that resource group. Same here for the location. I have a resource group section, and inside that section I have a property or a key value pair called location. Okay, that's important. Why I'm talking about that is that this will help you understand the structure of that PowerShell data file. And look at this. Inside of my PowerShell data file, which is of extension PSD1 for PowerShell data file, I have a section called resource group and key value pairs here. The name with the value and location with the value. Okay, so here, as you can see, my partial data file has a particle here stating for which environment I'm running the test, and here it's prod. So if I have multiple environment, I could have multiple files. Let's say I have another one called dev, which will has the same structure, but the values will be for the dev environment. Make sense? I hope so. And the final step is to actually run the test. So in order to run the test, here I'm working with PowerShell or Pester, actually, Pester version 5, which brings a new syntax. So if you are on a PowerShell, not PowerShell, but Pester 4 or an earlier version, the syntax is slightly different. But here I'm on the latest version, Pester 5, and Pester 5 requires us to create an instance of a Pester container in which we'll specify the path to our test files along with data here, which is the parameters that we'll pass to that test file. And if you recall, what we had as parameter for this test file is the resource group name. We pass the value here, and the path to our partial data file, which value is passed here. Now we create another object of type Pester configuration, and in that configuration we specify this container. Okay, so we point to that container, and finally we invoke Pester with this configuration. Okay, so it's 3 steps: the container, the configuration, which references the container, and finally invoking Pester, referencing that configuration. And that's it. If we run that test in the console, we'll have a set of tests, and we'll have some lines in green for the test that succeeded, and some lines in red for tests that failed. Okay. So can we use Pester in order to do TDD or test-driven development for our infrastructure as code approach? And the answer is yes, and it is actually the recommended approach. I would recommend that you start by writing the test describing the expected structure of the infrastructure to be deployed or to be updated, even before you write that infrastructure. Then you run those tests. Obviously, your new test should fail while your existing test should pass. I hope so. And then you write your infrastructure as code script for the desired new or updated infrastructure, and you run the test again, and that this time those tests should succeed. And if there is a need to refactor your code, then you will refactor your code. And here I am mainly referring to the IAC code. Okay. Now, can we run Pester inside a CI/CD pipeline? And once again, the answer is yes. As you can see here, we have a task to run our Pester test. Okay, so you can see here it's a task of type PowerShell, and what we are doing here is to invoke Pester with the parameter -ci for continuous integration. Next, we'll use another task to publish our test result in the NUnit format. Okay, and this will why is this interesting? Because if you do that in Azure DevOps, for example, you will have a beautiful representation of your test results. So here you can find a more detailed example on our GitHub. So let me quickly take you over that, show you what it looks like. Here it is. You can find it here. So here we have our execute test file. You can see it's very similar to the one we've seen earlier. But what I want to show you here, the difference is that I written some more advanced tests. Okay, so here we have test for our resource group, the same same as what we've seen earlier, but I have also tests here for a service bus instance. And I want you to look at this test in particular. What this test is doing is iterating over the list of tags of that service bus namespace and validating that those keys are actually present. And if they are present, that means those tags have been applied on my Azure infrastructure. Then I want to ensure that their value is the appropriate value, the expected value. Next, I want to ensure that I have the current count or the appropriate number of queues in my service bus namespace. And finally, the third describe block here iterates over each of these queues and performs some tests over this queue, checking the name of the queue, the log duration, and the max delivery count, and every important piece of information or piece of configuration for that queue. Okay, you've probably noticed here that I haven't tested all the possible parameters. Should you test all the possible parameters? Not always, but you should at least test the most important parameters for your need. Now let's quickly look at the partial data file for those tests. So as you can see here, for the resource, I have 3 blocks. Remember, we have earlier we had only one block, resource group. So now I have 3 blocks: resource group, which is exactly the same as previously seen, service bus namespace, and service bus queues. So for service bus namespace, I want to show you here the tags. That's how you design a tag. So here I have a list of tags with 2 tags: the project tag with this value and the environment tag with this value. Here, the service bus queues, since I have multiple queues, I have an array of queues object. Okay, so it's an array here, and I have 3 queues with their own configuration. Okay, make sense? So that's pretty much it.
So that's it. Now you know how to use Pester in order to test your Azure infrastructure. Easy, right? For more great content like this, please visit festivetechcalendar.com. My name is Tidjani Belmansour. I wish you a Merry Christmas and a Happy New Year. Bye-bye.